Good day, viewers. What we're going to be dealing with today is logarithms and reading of the log tables. Logarithms, logarithms, and log table. What we're going to be telling you, it's going to be based on on a particular rule, which is log. I want you to see that in the notes. You can see this. If three numbers ABC are related as A raised to power B is equals to C, exponential form, then the component B is called the logarithm of number C to base A and is written in this format. And so this is what we are going to be dealing with today. What that simply means is that for you to have log A, B, and C is equals to C, it's the same thing as saying B is equals to A raised to power C. That means the log of B is C to base of A, which is I'm more or less saying what we have here again. And that's what this is trying to explain to us. You can see that log A, C is equals to B. Well, it's the same thing like what I've written up here, which means that the exponential, if you have something like AB is equals to C, the exponential, if you're going to write this in logarithm format, is going to give you log A, C is equals to B. And this is going to be applied in the rule of log table reading. Now let's look at these two other rules. If you have 2 raised to power 8 is equals to, 2 raised to power 3 is equals to 8. If you have 2 raised to power 3 is equals to 8, do you know you can as well write this as log two 8 is equals to 3. If you prove this, you realize that you have log 2 raised to power 3 is equals to 3, which is 3 log 2 to 2 is equals to 3. You realize that log 1, note that log A raised to power A to A is equals to 1. So it's 3 times 1 is equals to 3, which is 3. So this rule, it's applicable and should be used all the time when you want to solve problems such as mathematics, such as addition, subtraction, and multiplication. So briefly, we are going to look at ways we can read log tables. Having noted this particular rule in logarithm, If you have a table, I'm still going to bring that out in the resource that we are using. If you have a log table like this, this is called the Matheson. Let me write that out for you. We call it Matheson. We have the difference, we have the column, and we have the difference in the log table difference. This is called the difference, the mean difference, and these are the columns. So when you want to find the log table of a particular number, take for instance, let's go straight to an example now. I'm going to still be using the example inside this note. Let's say we want to find the this particular question. Two, 3 log 2, 3, 4, 5. Let's go to solve log 2, 3, 4, 5. What you need to do is you have to find the characteristics of this particular number, and the characteristic of this number shows that you are going to take this number to a notation standard. Let me explain what I mean by notation standard. You have 2, 3, 4, 5. Can you see standard notation? So what that means that you have to write this in standard notation, you have to write in 2.3 times 10 raised to power 1, 2, 3. Because you are moving backward, it's going to be positive. We have 3. This is notation standard or standard notation. If you are told to find, this is the first thing you have to do. If you want to find standard notation for 0.0.456, the notation standard is going to be 4.5 times 4.56 times 10 raised to power 1, 2, 3. 10 raised to power minus 3, because you are moving this, in this instance you are moving like this, in this instance you are moving to the right, so it's going to be minus 3. So it's after you've written this, then you can now proceed. If you have, let me take for instance, if you want to solve this particular question, we have log 2, 3, 4, 5. To solve the question, you write it like this. 3, because it's positive, dot, remember this is 4, 5. You now have to look for the mantissa of 23, mantissa of 23 under the column of 4, with mean difference of 5. Let me explain what I mean. Goes for mantissa. Mantissa goes for colon, goes for mantissa, colon, and this goes for the mean difference. And to do that, number one, the first thing we need to write, we have to write the notation, which is, because this is 3, you put 3 here, it's positive. And then you can now look at the log table, taking into consideration all these things. So what's the mantissa? The 23. If we look at 23 now, the mantissa for 23 is going to give us, this is mantissa for 23. Can you see where my 23, 4 colon 4 difference 5. 23 colon 4, this is it. 3692 difference 5. Difference 5 is going to give us 9. Difference 5 is going to give us 9. So we have 3692 plus 9. 3692 3692 plus 9. Three six nine two plus 9, which is going to give us 3.36. In fact, it's going to be 37. Then this is going to give us 0.1. So this is what log, if you are reading the log table, this is what we are going to get. Log 2345 is going to give us 3.3701. Okay, now to find the antilog, now we've gotten the log of 2345. To find the antilog, we have to use the same concept to look at the antilog table of our logarithm. And to look for the antilog table of the logarithm, at the mantissa, we're going to look at 0.37. That's going to be our mantissa. Remember, it must always be positive. Mantissa must always be positive. Under colon 0, colon, and the mean difference of 1. Under colon 1. We realize that we'll get a value, this value 2, 3, 4, 5 back. When we add everything together, this is the value we are going to get. And this can be shown as we are, if you look at this, this is anti-logarithm tables. We have 37 under 0 plus 1. Can you see this is the mean difference area, this is the colon area, this is the mantissa, as we have talked about before. This is the mantissa. We have 3701 as our log value, but when we are going to get the antilog of it, we have to 0.3701. 37, which is this, under 0, this is under 0, colon 0. If I take it up, you see it's colon 0. This is colon 0. You can see it there. And mean difference 1. Mean difference 1. Which is the same thing as what we got here. 37 under 0, colon, mean difference 1, mean difference 1, colon. So with this, we can use it to, if you're given a particular equation that looks like this, if you're given something like this, equation that looks like solve log 2, 3, 4, 5 over log 0.0046. Just know that you have to use the logarithm table, log table, to solve this equation, to solve this particular problem. If you are given solve log 420 minus log 320 minus log 320 over log 640 log 640. Convert this to a logarithm table. Subtract this from this, and convert this to a logarithm table also, and divide this from what the value you have here. That should give you the solution. Thank you for listening. We're still going to do more examples that will help us to clarify the logarithm table and how to work with them, and that involves more equations such as this that is written here. Thank you. Stay tuned.